Hi everybody, today I am going to handle a class on software security and the reasons for insecure software and why and what to do to avoid the risk involved in securing softwares. Let me start with software security is the idea of engineering software so that it continues to function correctly under malicious attack. It also aims to avoid security vulnerabilities by addressing security from the early stage of software development lifecycle. Security is a risk management. How do we build it? It's all about building secure software. The process of designing, building and testing software for security. Building security into the software as opposed to securing it after building it. So good secure software is the need of the day, which leads to reduction in the expense incurred in fixing bugs in a software. Your software isn't secure, it is not going to stay in the market. So why software security? So most software systems today contain numerous flaws and bugs that get exploited by attackers. New threats emerge every day. Convenience trumps security measures. So exponential increase in vulnerabilities in software systems. So programmers have long history of repeating the same security related mistakes. Hence, these are the reasons why insecure software occurs. Let us see what are the reasons for insecure software. Reliance on network devices. So growing internet connectivity makes it easier for hackers to hack the system. Easily extensible systems. So extensions increase scope for software vulnerabilities. So increasing complexity of software needed to build. For example, Windows XP had 40 million lines of code. So what can we do? Building security into the software from ground up important to include security into every phase of the software development lifecycle. Why? Software security is a system-wide issue that involves both building in security mechanisms and designing the system to be robust. So you can't spray paint security features onto a design and expect it to become secure. So most approaches in practice today involve securing the software after it's being built. These are some terms. Now, defects. These are implementation vulnerabilities and design vulnerabilities. So bugs are implementation level errors that can be detected and removed. Example, buffer overflow. Flaws are problems at deeper level. They are instantiated in the code and present or absent at design level. Example, error handling problems. Failures are the inability of the software to perform its required function. Risk. Capture the probability that a flaws or bug will impact the purpose of this software. So vulnerabilities or errors that an attacker can exploit, either flaws in the design or flaws in the implementation. So design level vulnerabilities are the hardest defect to handle. So these are the process of managing risk associated with the use of information technology. It involves identifying, accessing and treating risk to the confidentiality, integrity and availability of the organization assets. So let us see what is confidentiality. Confidentiality means unauthorized user cannot read information. Integrity, unauthorized users cannot alter information. Availability, unauthorized user can always access information. So these are some kinds of risk. How do we manage them? First is identify assets, identify vulnerabilities, identify threats, identify controls. So now let us see identifying assets. What data, systems or other assets would be considered for your organization? So you have to identify that. After that, identifying vulnerabilities. Identify what system level or software vulnerabilities are putting the confidentiality, integrity and availability of the asset at risk. So what weakness or deficiency in the organization process could result in information being compromised. So we have to identify that. Next is identify threats. So identify what are some of the potential causes of asserts or information being compromised. For example, in an organization, the center located in a region where environment threats like floods are more prevalent. Our industry peers being actively targeted and hacked by a known crime. So this is a cause. So identify controls. What do you do already have in place to protect identified asserts? A control directly addresses an identified vulnerability or a threat by either completely fixing it or listening like likelihood. Impact of risk being realized. For example, if you identified a risk or a terminated user continuing to have access to a specific application, then a control could be processed that automatically removes users from the application upon their termination. So you can terminate them. Once a risk has been assessed and analyzed, an organization will need to select and treat the option. So make a treatment process. So that is called remediation, mitigation, transference, risk acceptance, risk avoidance. So risk remediation is implementing a control that fully or nearly fully fixes the underlying risk. So you have identified a vulnerability or a severe attack where critical asserts are stored, and you apply a path for vulnerability. So that is called remediation. So mitigation, lessening the likelihood and impact of the risk, but not fixing it entirely. So for example, you have identified a vulnerability or a severe where critical asserts are stored, but instead of patching the vulnerability, you implement a firewall rule that only allows specific systems to communicate with the vulnerability service on the server. So this is a issue. Now transference, transferring the risk to another entity so your organization can recover from incurred cost of the risk being realized. Example, your purchase insurance that will cover any loss that would be incurred if vulnerable systems are exploited. So this should be used so to supplement risk remediation and mitigation, but not replacing them altogether. So that is the next one is risk acceptance, not fixing the risk. This is appropriate in case where risk is clearly low and the time and effort it takes to fix the risk cost more than the cost that would be incurred if the risks were to be realized. Example, you have identified a vulnerability or a severe but concluded that there is nothing sensitive on the server. It cannot be used as an entry point to access other critical assets, and successful exploit of the vulnerability is very complex. As a result, you decide you do not need to spend time and resource fix the vulnerability. So next one is risk avoidance, removing all exposure to an identified risk. Example, you have identified servers with operating systems that are about to reach an end of life and will no longer receive security patches from the OS creator. So these servers process and store both sensitive and non-sensitive data. So to avoid the risk, sensitive data being compromised, you migrate the sensitive data to newer patchable servers. So the servers continue to run and process non-sensitive data while a plan is developed to decommission them and migrate non-sensitive data to other servers. So this could avoid the risk. So risk management, as we have seen earlier, we are looking into this diagram. One first step we have to take is identify the risk, then we have to evaluate the risk, treat the risk, handle the changes. So in identifying a risk, we have vulnerabilities, threats, asserts, impacts, incidents and advisory standards, etc. So when you the next step will be evaluate, you devise some strategies and policies, risk appropriate and tolerance, then you treat the risk. So when you treat the risk, you have to avoid, mitigate, share and accept. So then handle the changes. So this is the risk management process. So once you do this, the information security from this session, you could have clearly understood software security and risk management.